Okay, so where we left off, we were finding VB final X. We were about to put in the 6 kilograms down here for the mass of the ball. And so the final velocity of the ball in the X direction, when you type this into your calculator, you get 1.15485 meters per second. And try not to round too much here, because when it's small numbers like this, when you round in the intermediate steps, it really messes up your answer. So now we go to the y direction. So m of the ball via the ball initial y, m of the pin via the pin initial y, has to equal m of the ball via the ball final y, m of the pin via the pin final y. If we look in the y direction, initially, well, the pin's not moving at all, so it goes to 0 initially. And the ball's only moving in the x, so it also goes to 0. So bring your m of the ball, v of the ball, final y over, and it'll be equal to m of the pin, v of the pin, final. The y component, if you look, is the opposite side, so it's sine theta. So divide by the mass of the ball. So v of the ball, final y, will equal m of the pin, v of the pin, final, sine theta, over the negative mass of the ball. So v of the ball final y will equal, pull a negative up front, the pin was 0.22 kilograms, its velocity was 3.6 meters per second, and the angle was 70 degrees, and the ball was 6 kilograms. So v of the ball final y is equal to negative 0.124 meters per second when you punch this in your calculator. And the negative means in the opposite direction to the pin. So opposite pin. In this case, the pin was going up, so the negative means going down. So up here, if we were to redraw this, and I'm just going to do it beside the diagram so I don't make the diagram too messy. This is our V of the ball final X, which was 1.15485, I think. 485 meters per second. And this is our y, which is significantly tinier, v of the ball final y, 0.124 meters per second. And of course the negative disappears because the negative just meant its direction and we just drew it in. So this is v of the ball final. So square them, add them together, take the square root, and then this is your theta. So when you square them and add them together and take the square root, you get 1.161 meters per second at an angle of, and the angle is 6.1305 degrees. And which way? Well, it's coming down from the original, so that would be clockwise orig. And this is, your final answer for number 36. Okay, let's move to number 37. Number 37 has two cars. Wow, is it blurry for anybody else or just me? Okay, so it has two cars. There we go, that's better. Car A, mass of 1750 kilograms, is heading south, and we don't know A's initial velocity. Car B, mass of 1450 kilograms, is heading east, and we don't know B's initial velocity. But what we do know is that they collide at the intersection. And after they collide at the intersection, they stick together, and they go off at a direction that is 31.6 degrees east, 31.6 degrees south. So right in there. And they go off with a speed of 35 point, I think it's 8. Yeah, 35.8 kilometers per hour. And it wants to know what is VBI and what is VAI. Okay, now you could change these into meters per second if you want, but you really don't have to because they're just asking for speed. This will be V final in the X direction, and this will be V final in the Y direction. And all we're going to do is sum of the momenta again. So in the x direction, MAVA initial x plus MBVB initial x. Now, after the collision, they're locked together. And so you could write this as MA plus MB, V final, x. Okay, in the x direction, B is moving in the x, but A isn't. So this goes to 0, and we're looking for VBI, which is really the same thing as VBIX. So it'll be MA plus MB, VF, and the x component is the adjacent side, so it's cos theta, divided by MB. So VBI is equal to 1750 kilograms plus 1450 kilograms. And the velocity was 35.8 kilometers per hour times the cos of 31.6, and then divide by the mass of B, which was 1450. VBI equals 67.89 kilometers per hour east, or if you want that in meters per second, 18.68 meters per second, in case you did it that way. Okay, that's VBI. So you're done with that one. Now you want that's the x direction. So now we want to do the y direction. I might have room. So MAVA initial y plus MBVB initial y will equal MA plus MB V final y. And this time, it's the B that's not moving in the y direction. So this term goes to 0. And we're looking for VA initial. So VA initial, which is VA initial y, will equal MA plus MB. V final y, which is the opposite side, which will be sine theta. And then divide by MA. Fill in your numbers. 1750 kilograms plus 1450 kilograms times 35.8 kilometers per hour, sine of 31.6, divided by A this time, 1750 kilograms. And you get a VA initial, when you do the math, of 34.30 kilometers per hour, and that's south. Or if you want it in meters per second, 8.53 meters per second south. Okay? And that's it. So this one's actually easier than the other two because you don't have to do Pythagorean theorem and find the angle, because this time you were looking for the originals. Okay? So there's your 3 homework questions done. We're now going to switch to an example that's similar to these. If you remember from grade 11 physics, we had talked about some of the collisions were actually explosions. It would be like one person with skates on, maybe, standing with another person with skates on in the center of the ice. And then they push each other away. And one went back this way and one went back this way. And this was like VF1 and this was VF2. And sometimes you were told one of them and you had to find the other. And the key here was that V1 initial was 0 because he or she was just standing there, and V2 initial was also 0. And so they were called explosions. Another example would have been like a gun with a bullet in it, right? And so initially, both of them are at rest, and then the bullet goes one way and the gun kicks back. So we're going to do the same thing with an explosion example, except this time it's going to be 2 dimensions. Okay, so explosion example. And we're going to run out of time to do it, but we will start it and then we will switch. We will finish it in the next video. So it's a 30 kilogram object and it's going to explode into 3 pieces.